Hello, good day viewers. In this tutorial, we are going to integrate the function 3sin x plus 4 divided by 3 plus 4 sin x all squared with respect to x. This is not a simple function to integrate. Therefore, we are going to do a kind of manipulation here. I've wanted to divide the top and the bottom by cosine x. But you cannot easily divide the denominator by cosine x because of the power of 2. You have to expand it. So instead, we can divide the top and the bottom by cosine squared x. Apply one of the laws of indices. We can divide the input here, keeping the exponent as constant. All right, let's do that. Let me start with the top. So if I take the whole of this 3 sin x plus 4, and I divide it by cosine squared x, cosine squared x. This is the same thing as 3 sin x divided by cosine squared x, then plus 4 divided by cosine squared x. We can have 3 sin x here divided by cosine x times cosine x. That's exactly cosine squared x. And this remain 4 divided by cosine squared x. So sine divided by cosine, remember, is tangent. So we have 3 tangent x, but we still have 1 divided by cosine x, which is secant x. So we have secant x here. Plus, this is going to give us 4 secant squared x. 4 secant squared x. So this is exactly our numerator. Then for the denominator, we have 3 plus 4 sin x all squared. 3 plus 4 sin x whole squared. We want to divide this by cosine squared x. Apply one of the laws of indices. We can divide the input, keeping the exponent as constant. So we have 3 plus 4 sin x divided by cosine x all squared. So we have 3 divided by cosine x will give us 3 secant x. So we have 3 secant x plus, sine divided by cosine is tangent. So we have 4 tangent x whole squared. This is our denominator. We have the integral 3 tangent x secant x to the top, 3 tangent x secant x, then plus 4 secant squared x, plus 4 secant squared x. And to the bottom, we have 3 secant x plus 4 tangent x whole squared dx. This is our new function. Now I would like to let the whole of this input to be equal to u. So it is a U-substitution. Let u be equal to 3 secant x plus 4 tangent x. So we're going to differentiate the left and the right hand side. So we have the u here equal to, if you differentiate secant x, you're going to obtain tangent x secant x, but 3 is there, so we have 3 tangent x secant x. Then you move to the next one, plus 4 multiplied by the derivative of tangent x, which is secant squared x. So we have secant squared x dx. Just observe, the whole of this is exactly our numerator, which is to the top. Therefore, the top we have the u, to the bottom we have a u squared. So our integration becomes the integral of du over u squared, which can be rewritten as what? The integral of u to the -2, right? Du. This is equal to integrate this, you add 1 to the exponent, it becomes -1. So we have u to the -1, you divide by -1, you have this, which can be rewritten as what? -1 divided by u, then plus the constant of integration. You can equally add it here. But our original function was in terms of x, so we have to back substitute, bring back the value of u. And the value of u is nothing but 3 secant x plus 4 tangent x. So this is equal to -1 divided by 3 secant x plus 4 tangent x plus the constant of integration. And this is exactly the solution to this problem. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.